Okay, welcome to everybody, and thanks for participating in this talk, which is, let's say, a little trip of 10 years to mobile security, which is my field of research since the beginning of 2010, okay, something like this. Okay, so apart the various different citations of the Droid here, let me start introduce myself. So I was a PhD student many years ago at the University of Genoa and at the National Research Council. And at the beginning of my research career, I started working. I come from operating systems, so I started working on distributed architecture. So at the beginning, I wasn't, let's say, a scholar on security, but on distributed systems, in particular at that time on grid computing, for the early cloud. Then I started to do a postdoc on security, on cybersecurity, and in 2010, 2011, at the beginning, I started to do my own autonomous research, let me say, on mobile security. And at that time, there was a, say, mobile security is a little community with respect to the whole community of cybersecurity. And at that time was a rather non-existent security, community at that time, okay? And then I became a fixed-term assistant professor and then tenure assistant professor. And since October 2020, I'm associate professor in computer engineering. And I keep doing my research on mobile security right now. Okay? Okay, so I work with a group, like you, like all of you, of course. And this group, there are two researchers, one tenure assistant professor, which is Luca D'Abrame, which was my first PhD student. I started working on mobile security. And Enrico Russo, that works on virtualization and cyber range topics, which is a fixed-term researcher. And these are our PhD students. I won't talk about Andrea, that you know, so enough, I think, well enough. And these are, all of them are directly or indirectly my PhD student, and these are the lower row are the new ones. Lucky them, maybe, or not. Sorry, guys. Okay, and as you may see here, they all work on topic related to mobile security, apart some new terms like IoT security and security of software ecosystem. And you will understand at the end of this talk why this, let's say, funny name, security of software ecosystem, is indeed interesting related to that. Okay? Okay. And we had also some past former members, which was my previous PhD students. Simone is now working as a researcher and works on mobile malware on Android specifically at Eurecom in France, and Melanie is now working as a security consultant in a company, and I developed there a lot of proposal concerning mobile authentication. Okay, let's move on, and let's start to dig a little bit into this field that would be a bit novel to you. Maybe, and let's try to structure this presentation as a sort of 10 years challenge. I don't know if how many of you know what is 10 years challenge. 10 years challenge is an idea of old Zuckerberg, because I don't know if you know, but smartphones and mobiles are as old as Facebook. The first iPhone was being released in 2007, and Facebook was being released in 2007. 2007 was a year full of glory for computer science in general. And well, what I want to do is just a simple exercise to say, ask ourselves, say, what happened in 10 years of mobile security, okay? So this was a game, let's see, just to try to push, let's see, 4 people on Facebook, and let's do this game to see how we were and the first time we used Facebook, and then 10 years later, we'll do the same thing in mobile security, okay? At a very high level, but just to understand. So the question that we asked ourselves was, after 10 years of mobile security research, and meaning, take a look at these two. This is indeed my first Android device, which is HTC Desire 2. Android 2, version 2, I recall, exactly. This 10 years ago, and now you have in 2021 Samsung Galaxy X21, okay? Let's say as a price similar to iPhone, just to let you know. And there are 12 versions of Android in the. The question is, for sure, The second one is an improvement in terms of performance and so on. But is it likewise an improvement in terms of security? The question is, were we more secure in 2011 with HTC Desire, or today with Samsung Galaxy S31? To try to answer this. So what we are asking ourselves is, did things get better in 10 years? Okay, or maybe they got worse, we don't know. Or maybe, which is basically also in this case an interesting result to some extent, let's say that nothing has changed, like it happens for some people in the world, So basically we try to answer this question. So first of all, let me try to understand some basics, to let you be sure we are on the same page. I think that all of you, as a user, understand how the mobile workflow operates and works. Basically, there are code producers, developers, they develop their own application, and then put these, let's say, these pieces of code, this APK in the case of Android, on one of these storage, and there are code consumers that the user has access to these marketplaces and download the application they want. Okay? In the middle of this interaction, indirect interaction, there are security problems that we discuss in this talk. Okay? This workflow was originally born in mobile case, but also applies to other software distribution systems. Docker works in the same way. There are people producing and pulling some and pushing some images, and others that producing some install and so on and so forth. Okay? Okay. So in this workflow, the bad parts are application. Okay? The dark side of mobile security are application. Let me try to underline which is the problem here. Let's suppose you do a search on Google Play Store and write down bank. What you can see is something like this. What user leverage see is something like this. What people that work on mobile security see is just a bunch of, let's say, pieces of software divided into two categories. The first one is applications that are, by definition, vulnerable. Where you're a group of, let's say, software engineering, and you know that piece of software implies bugs. Mobile security and people working on security are interested in those bugs whose effect is not on the functioning of the software, but on the non-functional, let's say, part of a software that is security. So, say, our weaknesses are bugs that affect the security of the user of other applications of the system. But if these are pieces of software, they are, in the best case, vulnerable software. Okay? And the other set is made by malware, that basically are pieces of software crafted to try exploiting the vulnerability of the benign application of Google or whatever you can call it. Okay? So the big picture is that we have an operating system and this level of application. And from a security standpoint, there are two attacking models in this case. This malware basically aims at attacking and exploiting vulnerabilities both at application side and on the operating system, which is a piece of software vulnerable by definition. And this model is called confused attack, where the idea is that malware exploits good application, the vulnerability containing good application, and the good application isn't aware that it's doing something. Okay? The second model is called colluded application, which in this case you have two pieces of malware that alone doesn't seem so dangerous, but when they interact, they, let's say, do something bad in a, let's say, most complex and disruptive way. Okay? But we will focus here, to be more generic, on the first model of colluded application. Okay? Okay, so from a user point of view, what happens is that whenever you install an application, and the only role you have in this game is just selecting the application to install it in the middle of the units. Okay? It's just adding some pieces of software that contains, in the best case, vulnerabilities. Okay? So when you install an application, you take the risk of the vulnerability they are installing in the device, in your own personal device. Okay? So the big problem here is when you install an application with vulnerabilities is understanding how risky are these vulnerabilities. Okay? And the risk associated with a vulnerability is related to two values. The first one is the exploitability, meaning that how easy it is for an attacker to exploit that vulnerability. And the second one is the impact. Once the vulnerability has been exploited, which is the damage of the system to the user and so on. Let me give you a very simple example. Let's suppose you have a door, okay? And if the lock of the door is old, in that case, the vulnerability in the door has a high value of exploitability. So it's easy to open the door. If you have a new modern, say, door, in that case, the exploitability is lower because it's harder to open the door. The impact is related to what's behind the door. Once you have opened the door, if behind the door is just a matter of finding some dust and so on, well, the impact is not as low. If you find a lot of gold, well, in that case, the impact is. Okay? And the risk associated with vulnerability is just a coarse, let's say, product of these two values. Just to give you an example, this is an evaluation of an existing vulnerability, in which, as you may see here, the exploitability is high, meaning that these vulnerabilities are easy to exploit, and the impact is likewise high. The risk associated with this vulnerability is 7.8, which is rather high. Okay? So this is, let's say, what people that play the game of vulnerability assessment and penetration testing play every day when assessing the level of vulnerabilities in this kind of application. Okay, let me add another detail which is likewise important. Sometimes, if you don't belong to this world, you listen to these two words, let's say security and privacy. Okay, many people tend to think, also people working on in the security field, think that they are in some way correlated. You have people saying that privacy is a branch of security and so on and so forth. Just to give you a demonstration that this is not the case, and they are rather orthogonal, you know, engineers are precise people. Okay, so if the top conference in security is called IEEE, for engineers, you know, security and privacy, if security and privacy are equal, I won't think that they would spend a word more to say indicate something that is related to the first word. So they are orthogonal, and the same applies also on mobile. So let's suppose you read some news, something like there is a bug in the application or in the system, and the malware is able to exploit the vulnerability and steal your data. Okay? This is not a privacy problem. This is a security problem because there is a vulnerability and a breach. Privacy with mobile is more related to something like this. For instance, you have an application like WhatsApp and so on, which has been installed in a lot of devices and so on. And for each installation, there are some libraries, analytics libraries, if you know the term, that basically profiles you while you are using this and send all of this to the developer, to the app server of WhatsApp, so that the developer can see, can say, understand in which way the application is used by the 10 million, 10,000 millions of users. Okay? And some of these sometimes are sold in an anonymous way, whatever it means, and we discuss it, to some third party, Amazon, and so on. This is a privacy problem. Okay? As you may understand, the workflow are rather different. Okay, we'll discuss a little bit both of these cases if you don't fall asleep. Okay, so if we want to share, let's say, to do this exercise and start reasoning about how to divide the community of Droid security, let's move back to this model in which we have a vulnerable application, a malware that tries to some channel to interact and exploit the vulnerabilities of a vulnerable application. We can divide the effort in this research community in three families. Okay, this is a personal classification, so take it time and take it for what it is. So we have a community working on vulnerability assessment and penetration testing. Basically, this applies to static analysis applied, for instance, to the code of the vulnerable application, and penetration testing, which is more related to testing, focused on security, in which you basically try to test and execute the application to trigger a vulnerability. How easy it is to trigger and activate and exploit vulnerability. Okay? So the second effort is on hardening, meaning attempts that are made for, let's say, reducing the probability for a malware from another application to interact with number one. All the mechanism, the security mechanism that has been embedded in Android, discuss it in a little while, are focused on reducing the probability of this introduction. Okay? And the third family are malware analysts. Basically, this family of researchers focus on identifying, detecting, and dismantling malware independently from their interaction with some vulnerable application. They're not interested in the present. We just need to, let's say, it's a sort of antivirus plus plus. Not we want to understand the signature, the malware, and how they spread. And of course, they all have different aims, even if they indirectly cooperate. The first one is to make, of course, application less vulnerable, so stronger from a security standpoint. The second one is to remove as much as possible the probability of this communication. And the third is just to remove malware from the bind and whatsoever. Okay? Okay, so what about me? I just, for this talk, I did a very coarse-grained statistic on my papers. And so I tried to divide them in these three families. And it turned out that I work for 35% of my work are focused on vulnerability assessment and penetration testing. We discussed some vulnerability analysis of Android operating system, of vulnerabilities in the application, some approach to static and dynamic analysis, and some evaluation about privacy compliance, which I work also with the support of Andrea here. Okay? But most of my research, it seems, out of my research, being related to propose announcements that reduce the communication between malware and good web segment. Okay, so I work on bigger and device. We focus on anti-repackage and user control privacy. With this talk, I won't mention this for reason related to time. Okay, and I just worked and start working in this period of my life more than previous years on mobile malware analysis. Okay, okay. So let's start with our, let's say, little travel through the years of mobile security and Android security. So during the first years, the focus was on the blue channel hardening, building new solutions that allow you to reduce the communication between malware and goodware. Because the main aim of Android is this an old story, is to the Android security system is to say reduce the probability to zero in the case you install a malware that it can affect to some extent the operating system and other application. This is a desiderata more than otherwise. This has been achieved in practice in 2009. I maybe had studied something different and did a different research. Okay, so let's move to the basic of Android security right now, and let's see. Technically speaking, Android is a Java stack built on an existing Linux kernel. Application at the beginning was implemented in Java. All of these choices are commercial choices, were commercial choices, okay? Because the SDK of the first iOS has been released in 2007, and the idea was we need an operating system which is water secure, and in a way that we also are able to push developer to develop mobile application in Android rather than iOS. So a good idea was, let's take a Linux kernel that is a general purpose. There is a huge community that allows us to, in case, manage and patch security issues and so on, security vulnerability. Then we build, and then we use application written in Java, because at that time, Java was the most developed, say, most famous and used programming language, object-oriented programming language, okay? And the effort of Google was just to build this set of two-level of operating system, but that are built as a Java stack with some native libraries, you know? Okay. So at the time, the focus of the user search was on hardening these two levels, assuming that the kernel is secure. There is a hack paper stating the kernel is secure. So this is an assumption of that time. And the problem was, this which I started working on Android, is that there were no efforts in understanding the interaction between these two levels. As I told you, at that time, I came from operating system, and my main concern was, okay, I know rather well how Linux, the language, the security language of Linux, which is discretionary access control or something like this. And I also understand that there is a different language for application level, which are just permission like access to some photos and so on. I asked myself, do they integrate well? It's not so simple to take something out of the shelf and build on top of this Java layer. Okay, so we start asking ourselves if these two levels indeed integrate well. And if there are, this was a search question, some security mechanism, native security mechanism of Linux that has been, let's say, used in a non-canonical way due to this other security mechanism built on top in the Android OS. Okay, so basically we just developed a methodology to test the interaction and find if something went wrong. Okay, so what we discovered is called sandbox paradox. We call this sandbox paradox because the sandbox, the idea, please recall that the main aim of Android security systems is to, let's say, reduce that channel. So if you just think for say, a sec, you understand that a general purpose Linux kernel is just a multi-user operating system. Okay? So in order to enhance the separation between Android application, the idea was, let's sandbox them by installing each application as a different user at the kernel level. Okay? This is the idea of sandbox in a nutshell, and this is rather reasonable because two processes running as a different user are, let's say, more separated than two processes within the same user. Okay. The question is, do you know how Linux launches new application, new processes through fork? But the fork is a single user function. So basically, I fork a process of mine, which belongs to my user, and then I create a new process, and I inject some code that is the code of the new process. How can this be done if we separate application in different users? When you tap on an icon, this is an application that you need to start a new one. Okay? So basically, by taking a look at this, we discover how people from Google solve this problem. So just to, let's say, open with something that in Genoa is called Tapullo, okay? That, as you may see here, is just something, a way to make things work in a non-canonical way. And maybe at that time was, okay, we cannot fork as a user, and the only solution was we fork as root. And they developed this, basically when you tap on an icon, you just interact with this service that executes as a common user process that writes down a command here, and there is a root process here that keeps looking at this socket, and whenever there is a command, it forks create a new process and put the code to the application to run in this root process, and then change the ownership of this process to one of the launching application. Okay, funny thing, but the funny thing is that it is rather easy here to create a malware that bypass this step, writes down a write command, I won't go into detail here, that basically push this process to fork and create a process that remains a root process, okay? So you can use this to just do something like For instance, finding a fork attack, because if you put this in a while true, it's a rather simple malware, okay? What you achieve is something that you can see here. Basically, you keep building new process, new root processes, and so on. And what you achieve is that in the end, your resources, your RAM is full of dummy processes. And as you may see here, your device blocks. This is an example of a vulnerability in the operating system and a rather simple malware that exploits this vulnerability. Okay? So more in this rather old paper. Okay? Okay. And as you may see, the previous risk associated with the sample risk associated with the vulnerability was just the risk associated with this vulnerability, which is being deemed rather high, as you may see. Okay? Okay. The good news in this case is that once you find a vulnerability like this, the fixing is easy because it was just a matter of just changing some permission on that socket. Permission in the discretionary access control Linux model. Okay? So let's move on. And after this problem, during 2012, 2015, a lot of effort has been put on different sides to work on this hardening part in this communication. First of all, start to use some tools for implementing applications which are more reliable. The Eclipse plus the ADT plugin, something that I forget about it, okay? And they start to create new initiatives that are used in different situations right now. To some called bounty program. If you find a vulnerability, just let me know and I will pay you some money, okay? And they start to do some checks also on Google Play Store on some of this. This is Google Bouncer with the first anti-malware tool. Basically, it worked in this way. It took a malware sample, an application, it started executing for 5 minutes, and if nothing strange happens in 5 minutes, it is deemed say safe and benign, and put on Google Play Store. Rather simple because first malware just start and activate the malicious payload just after 5 minutes, and so you might understand why Google Bouncer at the beginning had some problem with this. Okay, and of course Samsung Knox. The problem, another drawback of using Linux, is that it's based on discretionary access control. So the permission to access the file of an application are decided by the developer. So if you are a developer which are rather stupid dependence, you just put 777 of permission in your home and then what you achieve is that all other applications can easily interact with you. To avoid this, the NSA proposed a porting of what is called C-Linux, Security Enhanced Linux on Android called C-Android, that basically allows to implement mandatory access control. Basically overrides discretionary access control, and cannot be, let's say, can let you be in a safe side with the mistake made by the developer. So more pragmatically, each manufacturer decides the security policy of this. So Linux and Samsung Knox is the example of an implementation of Samsung Knox. Okay, and they start to appear anti-malware of Android, and maybe some people also bought this wonderful proposal. As you can imagine, it was impossible for an application due to the sandbox we discussed to listen to what happened to another one. And so they are rather, let's say, not a good idea, okay? But if you spend money for this, you do it. And that was not a good idea, okay? So since all of these efforts have been put forward, and I can assure that from Android 5 to the next version, it has been very, very hardened a lot, okay, from several aspects. You should expect that in 2015, we solved the problem of Android security. This is 2015, more or less, okay? This is just some, say, news provided by big players in security like Trend Micros and so on. So it seems that we still have a problem with malware and vulnerable application. So the question is, why? Okay, because in that time, and this is just an excerpt of the number of malware at the end of 2015 that reached also almost 2 million samples. Okay, why? Because, well, is the price of fame. As you may understand, the problem is that during 2013, 2014, still now remains to operating system iOS that has between 13 and 16% over the year of the market share, and of course Android that is around 75 to 82. It's like Windows, a lot of people so have this operating system, so a lot of them find and attack this. And of course also on the other side, not only on the OS 1, is just related to the fact that you may see how many applications has been developed. And now we have around 3 million applications on the Google Play Store, more than the Apple Store. So there are more applications right now for Android than iOS. So you can understand it. Okay, so let's suppose that this is what happened in this, say, last part of the years. So what's next? Of course, this problem doesn't solve the whole problem of security. And let's suppose that there are no other things to harden right now. The simple approach is to work on both sides. Okay, so in this period, we have a hype in vulnerability assessment and virtual testing, a lot of proposals for static and mechanized application, and of course, rise of a lot of people working on malware, desktop malware, moving also to Android. Okay, so an interesting challenge at the time was what was called bring your own device security. Okay, so at that time, I also started working at application level, and the idea of BYOD, there were a lot of, let's say, articles, enthusiastic articles coming from economic journals and so on, say that bring your own device will allow companies to save up to 50%, 60% of their ICT cost if they allow to use your own personal device inside the corporate application instead of giving you two devices, just use yours. Okay? Okay, so the problem is that when you use your personal device inside a corporation, this one for instance, this should comply with some security policy. For instance, an example is if you have access when you are here to some corporate data, this must not be sent outside to some Bluetooth channel and so on. Okay? So the problem is that how to deal with this? Because at that time the proposal was just, okay, I give you the solution and also the device that was not so interesting. So we try to deal with this basically by adding what we call secure meta market, that basically is an ad hoc market where an organization can pull down some specification and security policies, written in conspect at the time. Okay, and basically the idea was that when a user wants to install an application, this market just retrieves the application, makes some analysis to verify whether it is compliant or not. So basically what we do is just creating a model, a static model of the behavior of the application that has a good advantage that is complete, but is also, let's say, too big sometimes. And then we apply some technique related to model checking and partial model checking to verify whether an application is compliant. Please note that this is not part. Remember the sentence, an application is compliant with the policy, because a false friend, okay, I will answer in a while. And of course, if this is not the case, we are able to instrument the application and send the instrumented application, that is the application that is being installed. But this is unluckily illegal, because this is a software distribution. We take an application, we change it, and we do what is called app repackaging. We discuss it in this talk. And this is illegal, so Google is not happy about this, but we solve the problem. So a working tapulo, in this case. And the working tapulo is that we send the original application with some instruction to how to instrument the application. So the instrumentation applies and is made at the client side, so there is no distribution. And we send a valid signature that applies only to the application that has been correctly instrumented. Okay? Okay, so this allows, and just to give you an insight, this solution has been we didn't build a commercial solution to this, but just a TRL7, if I recall well, proof of concept, because our aim was to do research, of course. But this has been, let's say, used and adopted at NATO agency in the Netherlands, so still in use. Okay, so this has been an experience useful to understand how to deal with static and dynamic analysis, more static than dynamic analysis of an application, how to model their security-related behavior, and so on. But this approach has some limitation. The first one is the scaling problem. The problem is, coming back to the false trend I told you before, when you install an application, you cannot prove it's insufficient to test whether this application complies with the policy, okay? Because the model of that application put in parallel composition with the model of the already existing application must comply with the policy. So the problem is that whenever you install a new application, you need to do, let's say, model check 1, 2, 3, 4, and so on. And our numbers allows us to come to behavior in a reasonable time using partial model checking to the model of 20 to 25 applications. This is insufficient for commercial product because on average on your device there are from 40 to 60 applications on average. Okay, so it's the first limit that we didn't solve. The problem is, what are these applications actually personal? Because the application I let you install is just a sort of an application that has been tweaked. Okay, that works well, but complies with this. So it's not rather personal because at that time there was no way to have, let's say, two different versions of the same application. Now we can have it through, let's say, complex, not so complex, but a novel technology of Android, which is called Android Virtualization, that I'll discuss in a while. And of course, the problem is corporate side. We build all of this and ask the corporation, okay, now suggest us some policy that you can build via policy. Which policies? Can you shut down the Wi-Fi connection? Okay, so this is the problem. Okay, so just if you want some other information, let's do that. But from this, let's say, experience, and from the limitation of, say, making analysis of a lot of applications, what we got is that we start moving bring your own device policy to vulnerability policy. So we try to encode some pattern of well-known vulnerability, so to discover them through static analysis. Okay? The problem of static analysis is that it generates, as you may know, a lot of false positives. So you may find that there is a potential vulnerability, but in order to prove that this existed, you need to test it, to prove penetration testing and analysis. And so most of the vulnerabilities to find through static analysis maybe are or low-level risky vulnerabilities or other that are, let's say. And so basically what we build is something like this. I won't go too much into detail of this, that are, say, a way to analyze perhaps single app and find out whether they are suffer from some vulnerabilities. Okay? Okay, so from this we move to from research to spin-off, and on top of this technology we built, we started a spin-off which is called Cybersecurity. Okay, and this product become a product for a systematic analyzing mobile application. It is called Approver. Okay, okay. So when you took an instrument like this, the funniest thing is that you can go to the Google Play Store, find some application, download application, test them, and so on. So the question is, do you think that if you're a user that wants to install an application, there are some applications that you expect that are more secure than others? I don't think that you are rather interesting, or you expect that Candy Crush would be, let's say, so built in a secure way. But maybe maybe, you think that banks should have some applications that are secure. Okay, so let's do the exercise of evaluating. We did this exercise taking 60 bank applications from the countries, the top ones. And let's do the exercise of evaluating their the risk of their vulnerabilities. The funny thing is that you should not expect that there are these kind of high risk vulnerabilities. Okay, indeed there are, and you may ask, okay, but 1, 2 out of 60? No, 2 out of 3 of these applications suffer from this. Very, very quickly, which are these kind of vulnerabilities? The first one is you find inside the application the hard-coded password of the database of the bank. Okay. The second is that they execute on rooted devices, meaning that in the rooted devices, anybody can do anybody, so you're root, and they should not work on the rooted device. And the third one is the SSL teaming, sorry, but basically the point that they interact with the server without authenticating the server. Okay, so the second and the third are rather, let's say, complex. The first, if I have time, is an important, let's say, point to discuss. You may think that putting a hard code, a password, is something which is very stupid. Okay, but think that people that start developing from mobile come from, let's say, other, let's say, development environment. So basically, most of them came from, let's say, server-side development, in which if you put a password, nobody enters. And so basically, when they move, they keep the same, let's say, the same way of thinking. Okay, but this is very interesting. Okay, so if you want to have some information, you can check the report. This is an example of a finding that you cannot publish because, as you may understand, the name of the banks are anonymous. Otherwise, you know, I will be me, Luca, and other will be somewhere else. Okay. Okay. So moving back, Paolo, let me know if I'm running too long. Okay, but I think sometimes I take a look at the timer. Okay. So 2018, we are almost at the end. So don't worry, just a matter of 15 minutes. Okay. Are we more secure now? So basically, what we did is trying to do something like this. So let me now ask you a question that we already discussed with Paolo. So when you install a new operating system, so there is a new update for your operating system or Android 12, which is being released in some months ago, you have the perception that this new operating system is more secure. From a logical standpoint, it's rather trivial because during a year, there are vulnerabilities discovered and so patched. No? So basically, if I ask you, of course, Android 12 is for sure more secure than Android 11 or 10, you may answer yes. I will answer no. Okay? Because we have a problem. Because the problem is that when you upgrade an operating system, the operating system comes with new features that previous operating system had not. Okay? Why? You may ask why. Okay. If you are a user, you understand that now there are some applications that in the past did not exist. You may think that these applications did not exist because nobody had the idea. No, sometimes they had the idea, but there are no features in the operating system allowing to develop that application. So let's move on. And the problem is that if they introduce new, say, new functionalities, they automatically enlarge back the communication channel between the two parts. So let me just give you some insight on this. This is the statement: new app, new operating system, and new threats. I think that all of you knows how PayPal works. How many of you use PayPal? Application? Okay, me too. So, okay. I used also one of those 20 banks, okay, in the previous, so don't worry. Don't worry. I can say that it's fine. Okay, didn't say with the name, okay, but it's the same. Okay, so everybody uses PayPal. And I think that all of you knows what a phishing attack is. Okay. Okay, phishing attacks was something like this. You receive an email. Phishing attacks were powerful 15 to 20 years ago because the user just was, let's say, unaware of some security problem. There was no anti-phishing emails and so on and so forth. Okay. And I also know that maybe some of you may use Password Manager on the web. Do you use Password Manager? How many of you use Password Manager? I also use Password Manager and keep using Password Manager on the web. Because Password Manager was, let's say, the end of phishing. Let me say something like this. You know, when you receive a mail like this and you click, and this is phishing, this moves you to a, let's say, to a website that is not the PayPal one. Okay? And of course, the Password Manager on the web authenticate and recognize that website as that is not the password, the PayPal one, and will not provide your credential. But you, as a user, maybe. There are studies that show that on average, the 4% of people receiving a spam email, let's say, answer yes and provide a credential. So keep using this. Why I'm telling you this? Because now, let's move on some application that cannot exist before Android 8, which are Password Manager on mobile. Okay? If you think a mobile application is just a front end of the website. You have the website and you have the application. So if you are, let's say, like LastPass or something like this, or this kind of password manager on the web, it's straightforward to ask for. Say we have a lot of password, and it's straightforward to create this application using also mobile. Okay, so they push to have this new feature. And in Android 8, they introduced Credential Autofill, which is a specific kind of service that you, as a developer of the application, can add. And basically, if you implement this service, you allow to bypass the sandbox. You are telling Android to allow a password manager to listen to your user interface, and in case, and to these two fields, and in case, inject your credential. Okay, it's a developer choice, but it's a lot. Let me introduce a new one, which is called Instant Tap. We know what are Instant Tap. Sometimes you navigate on your Chrome and so on, your device, and there is a pop-up like this. Let's ask you, oh, you go to this website. Try also the Instant Tap. Instant Tap is a business problem. Okay, the problem is that I'm just asking you as a user, when you buy a new smartphone, how much time do you spend in looking for applications? The first day, or the next one that you install, maybe someone suggests you this application and so on and so forth. But as you have seen, there are a lot of new applications, and the problem of Google is, okay, if people doesn't look at Google Play and install application, developer will stop implementing application for Android. So since it's a bit it's a burden to implement, to install a new application, if you don't like it, you just use this web APIs. You go on a website in which there is an application, try it. You just click on this, and some mobile code is downloaded and executed. And if you like it, you can install it. Otherwise, forget it. Okay? Okay. So a password manager on mobile works in this way, like in the website part. So basically, you open the Facebook application. It suggests the corresponding credential you use on Facebook, stornosite.com website. And the question is, how can a password manager on mobile, knowing that this is indeed the Facebook app? And so, on the website, we already discussed this. There is a PKI and some certificates, so it's rather simple to get. And so this is why password management on the web prevents phishing attacks. So use them. And the problem is that how they work on application. You know that each application has a unique name that, since the application came from Java, they resemble the format of a Java package. Okay, that are, say, similar to websites in reverse order. So any application has its own name, and this should be unique. It's like a primary key, okay, if we want to discuss from a database point of view, unique on the device and in the Google Play Store. But you cannot trust this package name because the package name are attack control. If I'm an attacker and I build my own malware and I upload it on Google Play Store, I give it the name I want. The only constraint is that it's unique on the Google Play Store. Okay? So, and there are no relationship like in the website, web part between packages and subpackages, and Google makes no restriction. Just to give you an example, this is an exercise that you can do right now. You can create an application, which is a void application, and upload, like we did, giving the name com.facebook.fake, the fake one. Fake is still on the list, but Google doesn't know it, don't worry. Okay, we are not related, unluckily, to Facebook, but we were able to just write this name from application. Okay, so we have a problem, and it is called the mapping problem, in which basically we have this channel, which is trusted, okay? The password manager used on your web. How this identification is made? Okay, so to do this, like we did on commonly, anybody can want to understand how an application works, it's just a matter of downloading it from Google Play Store when you want, and just do some reverse engineering using tools at the state of the art. You don't need to be particularly smart on this, and look inside them to see how they solve this problem. Be tranquil. This is exactly the password manager I use, so don't worry. Okay, but I don't use it on mobile because you want to be paid. Anyway, don't forget about it. Okay, basically, they use heuristics to understand the mapping. And if you just take a look at this, they just take the package name, separate it on the dot, and just in this case, take the first two in reverse order, okay? So, of course, com.facebook.katana is recognized as corresponding to facebook.com, but also our com.facebook.fake. And so as you may see here, this is not trick, is just LastPass suggestions to this application that is called com.facebook.fake. It has no relationship from a structural point of view, nor in the guy and so on, the original one, the password, okay? I won't go too much into detail, but Dashlane applies the same and take the first three characters consecutive to understand the corresponding domain. So basically, if you call your application the same as previous, you just rename the application like this, because I say fact, it's a little bit unpolite, they suggest the credential of Facebook, Instagram, and Uber. Okay? I use it to just play a short game with you. Okay, so we have Keeper. Keeper just trusts the name put on the corresponding page in the Google Play Store. So here you just write down, in your application, www.facebook.com, it trusts it. Okay? And so this is the same example as before. One password is rather useless, so forget it if you have fancy one password, because in the big game between usability and security, this is rather hard to be used because they do not provide any kind of suggestion. So if you just need to scroll all the passwords that you have saved, very secure, unusable, so let's make your own choice, okay? The first three are the best one. And the Google Smart Lock, which is the only one that works, okay? But because the developer must just answer to this form and say, okay, this is the package name, and this is the corresponding website, just writing down. And the problem is that the mapping is not public. So we will keep these secrets, it's rather complicated. Okay. Obviously, things can get worse because if I want to build my own malware, I just remove a field. So the user has the perception to just fulfill the username, and there is a hidden field that is just a programming trick in which that steals the password as well. Okay, so the game is, this is an important part of the game. Do you agree that this is a vulnerability? Okay, an application level vulnerability that affects password manager. Question. How risky is this vulnerability? So the question is, which is your perception? But is this a high-risk vulnerability like the Zygote one? Is this a low level or an average level? How many think that is a high-risk vulnerability? Okay. The bad news is that it's average. Average because you suppose that this is a high risk because you focus on just one aspect, which is the impact. This vulnerability allows the attacker to steal credentials. Of course, the impact is high, but unluckily, the exploitability is low. Because in order to steal Facebook credential, you need to force the user to uninstall the original application and install from some other app store fake com.facebook.fake, com.paypal.fake. And this actually is, let's say, rather difficult. So this is the problem. That is an average, so a yellow one in the previous. And so this is not, let's say, so publishable, at least not in a high level, high-ranking conference, security conference. Okay, so maybe we can solve the problem and try to increase the exploitability level. Okay, and maybe we can do this using Instant App. Okay, because from a security standpoint, Instant App is just mobile code that comes from somewhere. Okay, and installed and executed in the device. Okay. So the problem is when you just use a common use of Instant App, just you have something like this, you click open up, you download its code in this way after a couple of seconds, you have the application. But if this URL is controlled by an attacker, the attacker also controls the user interface because it decided what to execute in the device. Okay? So, and unluckily, Instant Apps have a package name, like common application. And so the password manager will autofill Instant App after they were installed up. Okay? So we can put all of this together to create so far the most, let's say, dangerous phishing attack on Android. And it starts the attack with an URL, like usual. Oh, try visiting this and try donate some money, okay, to, which is a translator, borderless.org. Medici Senza Frontiere, I don't know how to say French. Okay, so you reach an URL like this, you want to donate, and you have a link on this, pay with PayPal. And this is just an idea from the user. I click on this. This is just a command for my PayPal application. Indeed, this is an URL for downloading an Instant App that can be customized with the user anyway. This Instant App is named open without any icon and so on. Okay, so you click on this, then the Instant App is downloaded, and this is the result. This Instant App, the user has the perception that the Instant App is, that this PayPal is the one he has installed on his device, and it is exactly the same from a look and feel point of view, but it is not com.paypal, the original one, but .compaypal.email that is sufficient for last pass to sending your credential. In this case, we increase exploitability because it's just a matter of sending a URL and building a crafted, malicious, because this is a malware, okay, application. There is a solution, I don't want to go too much into detail, which is the one applied by Bartlock. You just put a JSON file on the website, okay? In this JSON file, there is the name of the true name of the application. Basically, when you have something like this, the password manager can navigate to this link and check whether the name is the expected one. So we ask yourself, it seems that this vulnerability does not exist in practice. It depends. So we try to see how many of these domain inside password manager applies this. In end of 2018, just only 2% applied this. This is an important lesson to learn because this is an example of vulnerability that cannot be fixed easily. The only way to fix this vulnerability is that a lot of, let's say, developers adopt the digital asset link technology. We don't know, okay? But in this case, you have let's say a vulnerability which is very high risk, affects the whole ecosystem, and can be, let's say, submitted for consideration in high level, high ranking conference. Just two important things that you may be interested to. Okay, when you find the vulnerabilities, what to do, because the situation is tricky in both situations I told you. Well, and from a political point of view, you need to wait 90 days before disclosure. Okay, so basically, in this case, we spent 110 days. Okay, and then we got some different reactions. On password, okay, we provided the suggestions, so it's a problem of mine. They are right in this case. Google say, oh, no, Instant App and Credential Autofill is our new technology. And of course, it's not a problem of us, it's a problem of password managers. Dashlane and LastPass gave us $120 that we are still waiting for them. And the other one, some gadget, and we are still waiting for them. Okay, that's the problem. And Keeper just read in a blog post that is rather smart, because they mentioned the problem of mapping, but they forgot mentioning the problem of Instant App, because they know that this vulnerability in this way is as available. Okay, we have a lot of discussion with this guy, but it's okay. And then in this case, we can find a vulnerability. Sometimes there are a lot of, say, press release also in the field of security and so on. Okay, I'm concluding, I promise, because we are in 2019, 2020. I want to add another step. So far, we suppose that we were able to, let's say, harden the operating system. And let's suppose now, this is the question. If we are able, in an hypothetical way, to remove all vulnerabilities in mobile application, are we safe against malware? If you ask yourself this question outside the world of mobile, maybe you may say yes, but not in the mobile world, because there is let's say, another problem, which is called app repackaging. So the idea of app repackaging is this. Here is just a search, a query on Google Play Store, very recent, looking for WhatsApp. As you may see here, there are a lot of WhatsApp applications, and as you may think and understand, there is just one official application. Okay, this is, let's say, the result of a successful app repackaging. We assume that the original one is free from any vulnerabilities, just a different problem. The problem is that the attacker sees this, as we did before for password manager, banking application, anybody can go and take some application, try to modify it, adding some malicious code, that maybe attack other applications, okay, or other operating system, and then reassign, redistribute them. Okay, so in all of these cases, as you may think, all of these are applications which are being repackaged from the original one. So we don't know what's inside this application, but for sure there's something not so good. Okay? Okay, so now the last problem I want to discuss with you is just how to counteract this problem. On Google Play Store, maybe there are some issues that we discuss, but it's still an increasing problem. Okay? If you just Google WhatsApp, maybe the first results that Google prompts us is just something like softpedia.whatsapp.something. All of those applications are repackaged. Okay, what's inside the repackaging you don't know. Let me move on. This is not this, as you may see here, indeed a serious problem right now in this case. Okay, so just a very quick update on this. So you know that step one, this is a classical workflow we discussed at the beginning of this presentation. There is a developer that develops some app in a let's say, utopistic world without attackers. What you have is that the APK is delivered here, and the user just downloads the message. But in this case, what we have is that the developer, just delivered the APK. There is an attacker that tries to find to download the application, analyze the APK, try to check whether there are some anti-repackaging protection that right now there are some proposals we discuss that are applied in this phase before releasing the APK, okay, after the application is being developed and so on. If it is able to neutralize all these anti-repackaging protection, it has some malicious code, just build a repackaged version of the application and then try to send them abroad or let's say upload them on the Google Play Store. There are some checks that have been carried out on the Google Play Store. Some, let's say, static analysis, basically, there are two applications. It's calculated a sort of distance between the two applications. It is lower than a given threshold. The youngest one is removed because it needs to be repackaged. That is probabilistic approach also in this case. And there are some proposals that do not apply in practice also for some dynamic analysis on the device. But the problem is here, the fight is between step 2, this anti-repackaging, and this. What can make your application safe is that you apply here so many anti-repackaging protection that in this try and error cycle at the end, the attacker will say, I need too much time to repack your application, and so I won't do it. Okay? So this is the game to play right now. And so basically the idea how to protect an application from repackaging is your original code. You just add some that are called logic bomb inside part of the code that when executed, so you release this version application, when executed, they just execute some tampering control if the application or that part of the application is different from, say, the version expected during the compile time, then something happens like making the application crash. Since that there are some, let's say, better than me on things related to software and engineering and so on, just give you a glimpse of how this works in practice. There is a common approach, but basically that is based on an hypothesis that could think is reasonable or not, but it seems that the research community think it's okay, which is a sort of information asymmetry between the developer and the anti-repackaging. The point is that the developer knows better than any attacker the actual values of the variable in the code. Why I'm telling you this? Because the idea is that when you reach something like this called qualified condition, when there is something v equal to some value const, in some original code to be executed, the idea is to just modify this condition, okay, by transforming that equality to this one. Basically, this is an hash, and this is the hash of the original code. But basically, the idea is that, and v is the key, and this code is encrypted, okay? And the value of v, which is const, is used at runtime to decrypt the original code. And in this encrypted code, there is the original code and some tampering detection. Tampering detection is just request the operating system to check part of the APK file. This is the idea. This is one of the, let's say, more promising idea. And but there are some limitations that you may understand just looking at this little piece of code. Okay, bombs are easy to detect because the quality condition is the same, so you can instrument them, and by just doing some, let's say, wise instrumentation, you can pass a lot of them. There are little involvement of native code, so all of these bombs are, you know, that by application have a Java part and also a native part. All of these controls are carried out leverage on Java, and there are a lot of tools for analyzing Java, as you may know better than me, and so it's rather easy to detect them. There are no obfuscation of this code, so it's rather easy to see this. And the problem is that there are right now 5 proposals in the previous year, 1 per year, and this is a really annoying thing, according to my idea of open science, because there is just one tool available. There are papers in interesting venues and so on, but there are no availability of this. Okay, but am I just playing the game of looking at the SOTA and saying that they don't work for some reasons since I don't have the tool? Okay, let's see. Prove that some protection in the hardening part, the blue part, is rather useless. You need to fight and prove that they are effective. So we did this by taking an application which is not protected, another anti-mine game like this. We apply NRP, which is the most advanced solution so far that applies some check also on the native code. And we protect it with, let's say, a lot of, with the configuration with the highest possible, say, protection. And this is an example of the protected APK in which there is anti-tampering in encrypted part that basically check the classes.txt, okay, the value. So there is a link to this classes.txt, that is the original executable of the application, and an hard-coded of the expected value. Okay? So basically, we were able to modify as it follows: the app to be repackaged, we just rename classes.txt class.txt, which is the original one, change the path to this. The anti-tampering passes this check because this is the original one. And we have our classes.txt, in which we put also our malicious code and has been successfully repackaged. Okay? So it seems that it doesn't work in practice. So if you want more information about this, very quick on this, because I don't want to say something about this is our proposal to enhance the state of the art, which is very recent, which is called Droid. Arman is the methodology, which we try to, say, bypass all the limitations we discussed. We have a lot of, instead of using just one bomb, we use 6 bombs that have complicated things because some part of the bombs are native, some keys are native, and so on and so forth. As you may see, and another important thing is that this tool is available, is already Dockerized, so you can use it. And so far, it's still being extensively tested on 30,000 applications. And of course, it depends on how many protection. It can affect more protection, more overhead in terms of space. But in terms of time overhead, it's reasonable because the overhead is just at plus 3% of time. So we are waiting for the community to say if it works or not. Okay, so I won't go too much into this detail. Okay, so this is the link. You're welcome. Okay, so I won't go into this detail. Okay, it seems that with Arm Droid we solved the problem, and this is one of the last important points to share with you, is that as soon as you find a solution, there is something that complicates that solution. And I come to this idea, novel idea, of Android virtualization. The virtualization is this idea. So the possibility to have a container that is a sort of sandbox in which you can have an application that executes inside this container. And this container is just, let's say, proxy between the operating system and the application. But basically, the point is that this proxy, it is basically has full control over the application. It can, for instance, mimicking the answer of the operating system. So if just want to repack this application or just try to execute an application with anti-repackaging, when there is an anti-tampering control, this proxy can just give to the application the answer that it expects. There is a problem. And it also doesn't need to repack the application or insert the malicious code. It's just a matter of adding the malicious code running near the application. So this makes things a little less complicated. I don't want to go much into this. This is a paper that we presented next Friday at AXAC. But we solved this problem by just adding some, assuming that there is a trust container, as it is like any Google Play service or something like this. And of course, we protect this against anti-repackaging by dividing part of the code to some external code or DEXs that are executed only when the plugin application is able to authenticate, let me simplify, the trust container, okay? But just to conclude, the important point I want to tell you, a couple of minutes and I finish, I promise. Let me say just something about privacy. You recall the problem of privacy. I don't know how many of you have installed some application in recent years, last years, 2 years ago. Okay, the funny thing is that Google, certain time, discovered, wonderful, that applications just keep profiling you through this analytic library, the model we see, the threat model we see, and so forth. So basically they, and this is an example, that a lot of information can be assessed, and they decided that your application must prompt you a privacy policy. Okay? Do you recall some privacy policy when you install an application? Neither do I, but this is an important point. Okay? So they just write some Google privacy guideline that any application that assess PSI, so personally sensitive information, should comply with. For instance, you got information like this in which you open your Facebook data and discover it has a lot of information that this is not expected. Well, or at least you were not made aware by the fact that it is collecting something like this. Okay? So basically, this is a sort of guidelines, something which is rather reasonable, nothing complicated. Let's say the problem of prompting this privacy policy before, and that should be accepted by the user before start collecting and so on and so forth. And this is what we did with the help of Andrea and his background of, let's say, machine learning. Basically, we test a lot of applications in the wild and their privacy policy. We discovered that only 0.9% of the application actually complies with this privacy guideline. This could be a little worrisome. Just to let you know that recently, I don't want to say that this work affected this choice, but this guideline has been rewritten in a, let's say, more conservative software way, and so let's wait and see. When I come here, the last point to discuss is, some people may say, okay, but this is just a number paper. I mean, you are saying that this is not that 99.1% does not comply, and so on and so forth. So you may ask, but is it really a problem or not? So the question is, how many data are collected? Am I just worrying about a policy where actually applications do not collect a lot of personal information? This is a reasonable research question to give. And so, just to conclude this point, this is what it happens after you accept the privacy policy, if there is a privacy policy. Okay? They start collecting and send this to the Facebook server and so on. The problem is that after you accept the privacy policy, you don't have any kind of control over the kind of data that has been collected. It would be nice if you could, in some way, build an application or a service that allow you to choose how many or which kind of data can be collected. Because if you think you have, I'm worried more about banking or Facebook that collects my data than can be crash cyber, because I won't provide so many information with respect, for instance, to a bank or Facebook or such. Okay? So to answer if the problem is real, is just to give you an example of an empirical test. This is how many applications adopt these libraries. Most of them, the principal libraries came from Google, as you may expect. And so just think of how many information Google, Facebook, and so on basically gather on them. But which kind of information are gathered? Okay? The problem is that there are some, let's say, well-defined events in these libraries, but most of them collect custom events. Custom events that are application dependent. Basically, it's just an idea. I don't recall exactly, but this is sort of 5 minutes. This is the number of events that are collected, so the problem is real. So what we can do in this case? What we can do is just to build an application like we did with SQLite Droid, you can also like this, in which for each application you can set a different level of privacy. What does it mean in practice? This means that this tool basically applies some anonymization techniques with different parameters on the kind of data that are captured by the library. So this is an example. This is the original data that the analytic library applies, and these are, most of them are multidimensional data, and there is a bunch of 10, 15 years, almost 10 years, 20 years old literature on how to anonymize from anonymity and diversity to closeness and so on for multidimensional data. We have differential privacy can be applied, or different approach also to, let's say, we have a bunch of tools that can be applied to anonymize according to different levels this kind of data. So the approach is that, as you may see here, we just change, we remove some value, okay, according to these algorithms like anonymity, basically, or and differential privacy. We are implementing this, and the result is that we send to the server just some anonymized, some partially anonymized data. Okay, so we ask yourself, okay, how happy are the server side or Facebook and so on? You can answer yourself, I don't mind, but it is not so polite. So you just try to understand what happens when we try to do this modification. The main problem we have is that with Firebase Analytics, this is a technical problem, because it is in the way in which we resend the request and we expect to be solved. But the acceptance rate of our modified and anonymized set of events from analytic library, from the backend of analytic libraries, is rather high. Okay, so we can in some way customize, give to the user some form of control on the personal data that these analytic libraries basically take. No, I want to use T because it's intellectual. This is the point. Okay. Okay. So to conclude, what about the 10 years challenge to sum up here in 2021? The good news is that the number of malware in the end start to decrease. Okay? This could be a good news. Let me say that we got slightly better. But this can also suggest that something are changing. So to sum up some final consideration. The problem, as you've seen, we solved the problem with web packaging, and we have virtualization application and so on. We solve a problem, and then there are new features that introduce new vulnerabilities. Cybersecurity at large, and also it was also for mobile security, is a moving target. Okay, meaning to find a solution that is good for today, and maybe tomorrow things changes. Or as, for instance, Dieter Goldman said that basically security is a travel, not a destination. Okay. Or another important citation for Bruce Snyder, it said that security is a process, not a product. Okay, and this is another important thing. But in this specific period of time, is moving faster with security because the mobile ecosystem is changing. If you just recall what I told you right now, the whole set of problems we discussed have a well-defined boundary. The mobile smartphone. So the boundary is the smartphone, no? So it was till now mobile a closed world. Okay? The problem starts and ends within the device. Now we are moving closer to open world, sorry, because we are just the mobile device is being part of a more complex system that interacts with IoT, cloud, and so on. So, new threat models, a blurred attack surface because you cannot say where this is, let's say, executes rightly, So where is the end of the attack surface or not, like in the previous case, and part of the current solution, like in the case of Arm Droid with virtualization, can be good for some environment and not for the new one. So basically, this is what we are start dealing with mobile. Okay, this is the complex system, and we move from an environment in which this is the boundary, and the only concern is the dark side are the application inside the device, to something like this. And basically, we don't know what could happen right now. And to answer to this question, we just need to wait and see. And we see almost 20 years challenge in the next 10 years. Okay? Thanks a lot for being awake till now.
Alessio, very interesting. We have some time for questions. And well, for people who are attending remotely, please unmute yourself and make your question by voice, because I'm not reading the chat. Okay, so any question either from remote or from the room? There is one in the chat. Vincenzo, can you speak it up? Unmute yourself and speak.
Yes, I can. Yes. Ciao. Hello, Alessio.
Hello.
Thank you for the presentation. It was very good and very interesting. I have many questions, but I will start with one, then we will see. In the last years, Android and also iOS introduced the usage of biometrics data, like the fingerprint. Which kind of vulnerabilities this introduced for Android apps?
Okay, this is an old question indeed, okay? Because I started dealing with problem related to biometric, because biometric is one of the form, of the possible form alternative to what you know. You know, there can be two-step authentication. You know, something you have, and something you are. So something you are is related to biometric. The problem of biometric is not related to Android, rather than on the reliability, let me say, of the libraries that are used to identify you. Okay, there are two ingredients that needs to be, let's say, and that explains why we are having this right now and not 10 years ago. Okay, because the hardware part is more reliable, both fingerprint reader and also camera and so on. And also because there are things that I didn't mention, but I suppose, I'm not sure, that this part of routine that authenticates you according to your biometric and so on, would execute, I hope, in a secure part of the operating system, which is part of the hardening phase, okay, maybe in a trusted execution environment and so on. If this is the case, we are safe, and I don't think that vulnerability in the app can affect this. So because it's, let's say, app independent, no, this kind of authentication. If this kind of authentication does not execute in a trusted execution environment, but I don't expect this is the case, this is a problem of vulnerability, but also in this case at the operating system level. I think, to the best of them, there are some colleagues of mine that works on biometric authentication from 2010, something like this. I think they are rather reliable. Okay, from my point of view, it would be very interesting to try and test how reliable they are. Okay.
Yes, thank you for the answer. Yeah. Also, because there are apps that ask you for selfies and things like that, so they can scan your face.
Yeah. Well, the problem, just that they are discussing this, I was thinking, a problem, okay, if you use, and that could be something rather, let's say, unfair to say. But if you use biometrics in the authentication on iPhone, you are, let's say, more sure, I don't know if it is the case, than on, for the reason I told you, than on Android. Because if you have a top-notch hardware, then they work fine. But Android is also mounted in, let's say, entry-level devices. I'm not sure that the camera or these are a trusted platform module, a trusted execution environment. So it depends. It depends. I think that top-notch can more reliably use this kind of biometric authentication. Not sure on the, let's say, with the device that you can buy for your grandma, for instance. Okay. Okay.
Yeah, that was good. Thank you.
Okay. Any more questions? So I have one which is quite general. So you presented us this very interesting trip from 10 years ago to today on mobile security. And I remember that probably 10 years ago or around that time, one common thinking was, well, I will never access my bank through the mobile, but I will do it through the web because the web is more secure. So can you compare?
It's still true.
It is still true. That was my question.
Let me say something. Okay, I had a lesson to, I don't know, to translate the Università della Terza Età. Okay, which is basically university for older people. Okay, and this is rather complex to let them understand the problem. So I asked them a very stupid question. You need to choose. Right now, you have a lot of them have their own laptop. If they prefer to have their laptop stolen or their smartphone, okay. And the problem is that if you want to assess, it depends, okay. Because if you want to assess the website of your bank, what you've seen just here with password manager which are reliable and so on, is for sure more secure from your laptop, okay? But you cannot allow anyone to steal your smartphone because let's suppose that they steal your smartphone. Coming back to the question of Vincenzo, and you forget the password, or just you need to enter your bank. You need to use the smartphone because you have a PIN which is randomly generated, sent through SMS in the worst case. Or in case you lose the password, the way to is just another SMS and so on. The problem is that it's good to access via web, but you still need to have the smartphone because it's the way in which the backend service authenticates you, because the thing that you have waiting for biometric are not mobile on your system. So it's still true. It's still true. So if you want to access, I would like to access from my laptop rather than. But there is this intrinsic relationship between the two that maybe in some years you cannot think at one without the other one. Maybe.
Yeah, so this recalls me that, I mean, there's a recent trend of banks, but not only, which is to replace physical tokens with smartphones. Because I remember something that was very common a few years ago was every bank would give you some token of some form.
Yeah, I got it also in my bank.
It's almost useless because now all the functions are moved to the smartphone. So what do you think about this? Is it going to be same level of security, less secure?
No, it's more, let's say, from a practical standpoint, is reasonable. Okay. The argument used to generate this number, they basically use, let's say, stream key generator starting from the same seed, so it works in a way or in another. Okay, and the advantage is that sometimes it's easier for you to recover if you lose, let's say, the pieces of the random password generator. In the case you buy a new one, you install the application. There are some banks that make it tricky because you need to deactivate the first and so on, like Carige, just to cite one. But most of them allow you just to reinstall the application and you can access. Okay.
Makes sense. Good, thanks. Any more questions from the room, from home, Andrea?
So I have also a quite generic question, which is there's this famous quote that says, "Your system is as secure as your weakest link."
Yeah.
Right? So what do you think is the weakest link?
The user. No way. Let me try to. I'm sorry for non-Italian, but there are no way till now to make an utonto an utente. Okay, utonto means a stupid user, a user as I expect. And this is a problem of awareness, which is, let's say, an emerging topic in security, the cybersecurity awareness of the operation of the user. I must say that this applies maybe to other parts which are more core, but coming back to repackaging. The repackaging is the phishing of mobile. If I spend time to deactivate anti-repackaging and produce a lot of fake application, fake WhatsApp application, is because people download it, this kind of application. And so it's the same. The user is still utonto, but this is to be reasonable. The problem with mobile is that you can, on Android specifically, you can access to the install application also from third-party sources and so on, and if they are. So it's rather easy, like in the case of phishing attacks, sending an URL that you download an application, a new one, not replacing. But yeah, it's always the user. And the problem with the user is that problem we discussed. The more security you add, the less usable is the application, and the user will stop using it. And it's a sort of impossible optimization to find the right trade-off. Let me say something. I'm recorded, don't worry. No, that's very good that is it, because otherwise we need to develop the solution to reduce hard that communication channel. It is not a solved problem right now, more in this case, but this, let's say, more complex world in which you have a mobile, smartphone, it interacts also with OT technologies and so on, okay, Industry 4.0 and so on and so forth, so it's complicated, okay? But yeah, let's hope that this remains utonto for at least. Okay, I didn't say it, sorry.